The first step in the atomic theory history is Democritus's theory that iron, clay, and stone particles are made out of iron, clay, and stone particles. This was in 300 BC, and it was the basis of what we now know today as atoms. However, Democritus was not exactly correct. He wasn't wrong either, as we'll see in the next few scientists. But this was the foundation of atomic theory history, and it's what many credit with the basis and beginning of how atomic theory began. And it started the process that we will now see of how atoms were developed. In Antoine Lavoisier in 1780, he created the law of conservation of mass, which stated that if matter changes its shape, its mass will not change. And this helped scientists to realize relations between size of particles, the mass of particles, and how to apply that to atoms. So this helped to contribute to the idea that atoms have mass and shape and size. And so we started to see atoms develop more characters than we did previously. Dalton in 800 created his postulates, which the first of Dalton's postulates were Democritus's theory. The second was that all atoms of the same element are the same but unlike any other. And this means that if there's an element with variations, those variations will stay the same. The third is the law of conservation of matter. And the fourth is compounds are made of compounds of atoms using whole numbers. And this helped atomic theory by creating laws to help shape ideas and the foundation of how people see and use atoms scientifically. Next came the huge groundbreaking discovery of J.J. Thomson's electron discovery in 1897 with his plum pudding model, which gave the entire idea of what an electron is. Thomson wasn't wrong in assuming that electrons are in an empty space. He just didn't understand what he discovered. He knew that electrons had a negative charge, and he knew that they were found in a space of some sorts. Ernest Rutherford's nucleus discovery in 1909 with his Jaeger-Martin experiment, which saw him put a circular fluorescent screen around a gold foil and shoot a particle source at the gold foil. And he saw that the beams of light were reflected back to the particle source in different directions and straight through the gold. And he realized that there has to be a group of particles that cause this refraction of light, and he named this the nucleus. So this contributed to the idea of atoms having more subatomic particles than scientists originally believed. Again, Ernest wasn't wrong, yet he wasn't right either in hindsight. However, he did make this groundbreaking discovery that helped shape the idea of what an atom is, especially in the next person's model, which was fundamentally groundbreaking for how atoms are devised and understood. So Bohr's model in 1913 saw the first idea of a fully functional atom with its nucleus in the center, its electrons around, and orbitals. Now, he didn't understand what an orbital was, but he had an idea that electrons gathered or circled around the nucleus in a circular motion that orbited around. So he wasn't exactly wrong, but he wasn't right either. And he believed that electrons circled the nucleus like a planet would to a star, which is not correct. But he did know that orbitals had to contain a certain amount of electrons, which was based off of the next slide. Now, in 1904, we had the orbital discovery, which was what we base modern ideas of what atoms are comprised as currently. We knew what s, p, d, and f orbitals looked like in theory. But during this portion of time, we realized that we could not correctly identify where an electron was and how fast it was moving. It's just improbable. So we could only speculate on where it was and how fast it was moving. That's why we came up with orbitals. And each orbital can only contain 2 electrons, and that helped develop the theory of how atoms create and move in an atom. And so, s, p, d, and f orbitals was the newest way to visualize atoms. Next, we have the discovery of the neutron in 1932, and that was by James Chadwick, and he found neutrons by shooting a particle source at a sheet of boron, and that caused a radiation-like substance to happen on the other side of the boron, which he did not understand. Yet he put a sheet of paraffin after that boron, and that had a byproduct of protons. So he speculated that this radiation was particles that had to have the same mass of a proton, but it had to be neutral. And so we had the discovery of the neutron.